Welcome! In this lecture, I will describe some viral, fungal, and protozoan diseases of the nervous system. I will start with polio. The polio virus is a positive-sense, naked RNA virus. Most microbiology students know polio is the disease which crippled tens of thousands of infants and young children in the U.S. every year before the vaccine became available. It's the disease that forced thousands of children and young adults into iron lungs and onto crutches and wheelchairs. Polio is also the disease that crippled our 32nd president, Franklin Delano Roosevelt, or FDR. It spurred the creation of a historic and unprecedented funding drive for a cure, the March of Dimes, in the midst of the Great Depression. But most microbiology students don't know that in 90% of the cases, it simply causes a mild diarrheal syndrome. The virus is transmitted through the oral fecal route, mostly through contaminated water. In the United States, in the 1930s, 40s, and 50s, many children became infected through swimming in contaminated municipal pool water. The disease begins with a sore throat, where the virus gains entrance into the lymph nodes and lymphoid system. Next, the virus enters the bloodstream and central nervous system, where it goes into motor neurons. These motor neurons control muscle contraction. It is there that the virus does most of its damage, causing paralysis and respiratory failure in about 10% of the cases. The virus is shed in feces, where it can re-enter the water system and repeat the cycle in underdeveloped countries. Sadly, despite a huge effort to eradicate polio, it still exists in parts of Pakistan, Afghanistan, Nigeria, Cameroon, and Syria. There is no cure for polio, but safe vaccines have been available for over 50 years. The oral live vaccine developed by Sabin carries a 1 in a million chance of causing the disease, not in the child who receives the vaccine, but in unvaccinated family members who care for that child. The salt-killed vaccine is safer, but it does require needles, refrigeration, and trained healthcare workers to perform the inoculation. This makes it difficult to use in poor countries where pockets of polio still exist. For a fascinating historical perspective on the crusade to wipe out polio in the U.S., watch this YouTube-linked video by Paul Gallagher. How quickly we've forgotten just how devastating polio was to our country in the first part of the last century. The next viral disease I will discuss is rabies. The rabies virus is a negative-sense, single-stranded, enveloped RNA virus. The name rabies comes from the word rage because infected animals, including humans, become disoriented, often foaming at the mouth and maybe attacking others. Victims die of a fatal encephalitis in nearly 100% of the cases. Though it's rare in humans in the U.S., worldwide rabies still kills hundreds of thousands of people every year. India alone has approximately 10,000 human deaths due to rabies every year. Rabies is a zoonotic disease with mammals as the reservoir. Interestingly, in the U.S. at least, dogs are not the main reservoir. Instead, raccoons, skunks, and bats serve as the main source of this disease. Students need to be aware of this danger when handling animals from the wild. A relatively recent case involved a 12-year-old girl from Wisconsin who nearly died of the disease after handling a bat at her church. Check out this link for an interesting news story about her amazing recovery from rabies. Rabies is transmitted primarily through saliva, in bites, licks, and sometimes inhalation. The virus replicates in the tissues and in the peripheral nervous system. Slowly, it gains entrance into the central nervous system. where it infects the salivary glands and the brain. Some of you may remember that the salivary glands are served by cranial nerves 7 and 9. From there, easy access to the brain causes fatal encephalitis. The disease is unique in that the incubation period is extremely long. Whereas most viral infections have an incubation period of less than 1 week, rabies incubation periods average 8 weeks. Because of the long incubation period, a post or after exposure vaccination is possible. When a person has a known rabies exposure but no symptoms yet, they are given an active rabies vaccine to stimulate production of protective antibodies. Additionally, especially if symptoms are already present, the patient will receive rabies immune globulin, or RIG. RIG is a passive injection containing preformed anti-rabies virus antibodies. My little nephew was given both of these vaccines when he was bitten and scratched by wild monkeys in Bombay, India. When he was first injured by the monkeys, he went to a large, modern hospital in the center of the city of Bombay. His parents were told at the hospital that he would not be able to receive the vaccine there because of its high cost. They had to fly their son to Sri Lanka to receive treatment. Sadly, poor patients would not have had that life-saving option. Rabies isn't the only virus which can cause encephalitis. Arboviral encephalitis is a general term for a group of viruses which are transmitted by arthropods, mostly mosquitoes. There are dozens of known viruses in this group. Arboviral encephalitis is a zoonotic disease whose reservoirs include horses, as in equine encephalitis, birds, as in West Nile virus, and also small mammals. Depending on which virus it is and the immune status of the patient, symptoms can range from headache, fever, and chills to more serious symptoms of mental confusion and coma. Inflammatory damage to brain tissue can cause permanent brain damage, or possibly death in some cases. Most students have heard about West Nile virus, but don't know much about its history in the U.S. Prior to 1999, the West Nile virus had not ever been seen in the Western Hemisphere. It had been confined to Africa, Middle East, Europe, India, and Southeast Asia. The first American cases were seen in the summer of 1999 in New York City, where public health officials noted the disease was occurring in large numbers of dead crows and exotic birds from the Bronx Zoo. The initial human cases all lived within a short radius of the major international airports in New York City. It was concluded that air travel of humans or mosquitoes was the most likely source of this emerging disease. Over the next decade, the disease spread westward across the entire United States. Public health officials take the disease so seriously that they routinely spray powerful pesticides in residential neighborhoods in an effort to control the mosquito vectors. Check out this YouTube link to see a recent spraying in New York. It's kind of scary. For the infected patients, anti-inflammatory agents may help reduce the brain swelling. There are vaccines available for a number of arboviral encephalitis agents, but they are routinely only given to animals that are at high risk. This table illustrates 5 of the more common arboviral encephalitis diseases. I include it so that students can get an appreciation for the huge variety of etiologic agents, vectors, reservoirs, distribution, epidemiology, and mortality with these diseases. Don't memorize this table. Do appreciate, though, the variety seen here. And also, check out this cool link to the CDC website for an interactive map that shows each case of West Nile virus in each state for the country for the current year. Cryptococcus neoformans is an environmental yeast which is capable of causing meningitis. The name Cryptococcus means hidden coccus and is a reference to the organism's thick capsule. Diagnosis of the disease is usually made through collection of a spinal fluid sample, or CSF, and the demonstration of an encapsulated yeast in a negative staining technique known as an India ink prep. Alternately, latex agglutination is sometimes used. The natural habitat for the fungus is wet soil, but high numbers can occur in bird droppings, especially those of pigeons. The most common mode of transmission is through inhalation of the organism by agricultural, construction, or city maintenance workers. The inhaled yeast can cause pneumonia, as seen below, or they can enter the bloodstream and cause a fungal sepsis there. The worst cases are where the organism enters the central nervous system and causes meningitis and encephalitis. Even with treatment, the mortality rate is about 30%. The good news is that Cryptococcus usually causes disease only in those immunocompromised. By steroid treatment, HIV, diabetes, organ transplant therapy, or other medical conditions. Proper therapy would include bringing out the big gun antifungals, such as amphotericin B. The final organism I will discuss is a protist. Trypanosoma brucei is the etiologic agent for African sleeping sickness. Trypanosoma is known as a hemoflagellate because it can be found in the bloodstream of infected individuals, and it does have a single flagellum. The disease is confined to the African continent because the vector, the tsetse fly, is only found in Africa. There are two subspecies of Trypanosoma, Trypanosoma brucei rhodiens and Trypanosoma brucei gambiens. These diseases differ in their geographic distribution, reservoir, and severity. Both organisms enter the host through the bite of the tsetse fly, which subsequently becomes inflamed. Days or even weeks later, depending on the species, there is a progression of symptoms including headache, fever, decreased mental capacity, decreased physical activity, coma, and finally death. Untreated, the disease is usually fatal within months. The organism has a unique strategy for avoiding the immune response. Its surface protein antigens change on a weekly basis, forcing the immune system to start all over again each time. Recall that the primary antibody response takes 7 to 10 days. It's estimated that Trypanosoma is capable of changing its immunologic appearance up to 100 times within the course of a single infection. Because of this antigenic variation, the patient really only produces IgM, the acute phase antibody, and there is no long-term immunity for the disease. Approximately 500,000 Africans are infected, with 100,000 new cases each year. Prevention strategy involves killing or sterilizing the vector, especially in areas where humans live. Eflornithine is an effective drug in most cases. This concludes Diseases of the Nervous System, Part 3.